Welcome to my talk, which I call Misadventures with Terraform. This is a short tour of some of my personal experiences with Terraform, especially when things didn't particularly work smoothly, just like that sentence. But there were nonetheless some very valuable lessons that were learned. And obviously, as the title implies, the content is very focused on Terraform, but I think the lessons that I've learned from this are very much applicable to infrastructure as code in general. So if you don't know anything about Terraform, then don't worry, especially as I will start with a very brief introduction. So first and foremost, what is Terraform? Terraform is an infrastructure as code product developed by a company called HashiCorp. They develop all sorts of software for software as a service, for secret management, etc. And Terraform is their offering which allows you to codify and automate your deployments of mainly cloud infrastructure, but also SaaS products and other software, which they do using a series of a plugin framework, which they refer to as providers. Here's an example of a few vendors. I'm sure you'll recognize at least a few of those. Any vendor can write their own provider, and the full list is rather extensive and growing all the time. So how does Terraform do its thing? How does it work, essentially? So Terraform works on a declarative paradigm, which means that you don't give it commands and tell it what to do. You describe what your system, what your infrastructure should look like, and it determines what actions it should take. So the base unit of doing so in Terraform is a resource. So in order to use a resource, you need to tell it about the provider. So in this example at the top, you can see I've defined the AWS provider, so it knows that I'm going to try and use some AWS resources. And then at the bottom, I've defined a resource called AWS of type AWS VPC, which is the private network offering in AWS. And I've given it an arbitrary name of example. And then you can provide all the parameters to make it run. In this case, we've got just one, the /16 network address for the private network. Now, obviously, in the real world, that wouldn't be job done. You wouldn't just create the network. You would create, public and private subnets. You'd create other resources like route tables and internet gateways, NAT gateways, etc. But once you've done that once, that's kind of a pattern that you probably want to reuse again and again. Certainly, at least in your development environment, then your integration and your production environment. So you can then kind of package all that up into what Terraform refers to as a module. Essentially, that is just all files containing resources in a single directory. So to define a module, we've got a couple examples here. So we've got a module aptly named local, because the next line we define the source where we obtain that from, which is just a relative directory on the local file system. The second example, we've sourced it from Git, so you can also host your modules on GitHub or your internal Git repository, etc. There are also lots of public modules around, built by the community and even the vendors themselves. So there's one more thing that's of importance. So the Terraform Statefile. So Terraform basically keeps a ledger. It keeps all the metadata of all the resources that it's managing, and it saves this in what we call a statefile. Typically, this is stored in some form of persistent cloud storage. So in this example, we've defined the backend as S3, which is Amazon's cloud storage solution. We've defined a bucket, which is the base location and the full key. So we've got the example /terraform.tf state. And that's pretty much all that you need to know to have a bit of context about the scope of this talk. And then what Terraform itself actually does. So there are two things that you would typically do to apply what you've defined. You would run a plan, whereby Terraform builds up a picture of all the resources you defined, of how it thinks your system and your infrastructure should look, and then it makes a few phone calls out to the vendors to find out what's actually there, and then essentially brings back a diff and says, this is what I'm going to do. Say I'm going to create 10 resources, I'm going to update 2 resources if you make some changes, I'm going to delete a couple of resources if you remove them because you didn't need them anymore, and that is what you see in your plan output. And if you're happy with what the plan output says, if it says, I'm going to delete 500 resources, probably don't want to go forward with it. But assuming you're happy with it, then you would do an apply. And apply, it essentially does the same thing. It makes sure that nothing's changed since the last time you ran it, and then actually makes the calls out to the vendors to action what it's said in the plan. And then it saves that into the state file. So how did I get here? And I don't mean how did I get here. I mean the more metaphorical journey of how did I end up writing this talk. My career has basically much been, I started off as a systems engineer or a sysadmin, which meant it was my job to provision and manage servers, either in the physical or the virtual sense. And generally, you would do this with Bash. This was quite a long time ago. Obviously, things have moved on. There are sort of tools around, but more specifically, what's moved on is what we're actually managing. Certainly for the last decade or so, my job titles have always included the word DevOps, though I've always much erred more towards the ops end of the spectrum that is DevOps. But my roles generally consist of managing cloud infrastructure, SaaS and DevOps tools, monitoring and alerting, etc., rather than managing physical virtual private servers. And to start with, my toolkit wasn't that much more sophisticated, lots of Bash, lots of Python. There were some things around, sort of very much domain-specific stuff, so there was CloudFormation for AWS, for example, but obviously that only applies to AWS, so when you wanted to try and stitch things together so that you could then provision your alerting and your monitoring stack, you still had to do a lot of gluing. And then along came, about 2015, I started using Terraform, and for me it was a real game changer. There's still a bit of Bash and a bit of Python going on. I don't think I'll ever get rid of it completely. And why would I want to? Bash and Python's great. But this was sort of the first tool that was a bit more holistic in that I could describe vast swathes of our infrastructure estate, not just the cloud provider, but a lot of things as well, which really did sort of change the way that I worked with these sorts of tools. The latest release of Terraform is 0.12. When I first started working with it, it was 0.6. We're about halfway there, I guess, then. Some of the things that I take for granted today that I use on a daily basis, there are a lot of features and functionality that didn't exist then. So, for example, there was no way to define the backend, the state that I showed in the example. That didn't exist. You could only do that at the command line, so mistakes were very common. It was very easy to configure the wrong backend and make a mistake. There was no way to import existing resources and have Terraform then manage your existing resources. There was no way to interrogate the metadata that was in the state, no way to manipulate it. So if someone gave some resources some dodgy names, you were kind of stuck with it unless you wanted to destroy it all completely and build it back up again. And there was no way to natively lock the state file, which meant there was nothing stopping two actors, so either two engineers or two instances of your CI pipeline colliding with each other and completely messing up the whole thing. Now, like I say, we've moved on. We are now at Terraform version 0.12. And you think, oh, that's solved all those problems, right? They've implemented all these features. Those problems go away. Well, mostly, those sorts of problems, mostly. But those aren't the only problems that occur. And in my experience, the bigger problems are actually more to do with how we use the tool rather than failings with the tool itself. And so those are the kind of scenarios that I'm going to cover a little bit more now. So when I very first started using Terraform, I was working for quite a big company. And someone somewhere had made a decision and said, we're going to start using Terraform. And so they put together a Terraform task force. So a group of engineers that were coming together to figure out how we were going to use Terraform and build reusable resources that the entire company were going to use. And as you imagine, none of us really used Terraform before, so we went through that kind of typical journey as engineers do when we're playing about with things. We started off a bit rough. We just had one file with just loads of resources in it. It was a mess. It didn't really achieve much, except that we got our feet under the table. We understood what was going on. And then we started to get a bit more sophisticated. We broke it down. We started to build some reusable modules. And so, for example, we built a module to provision completely a VPC and with a bit of flexibility, so it could cover quite a lot of the use cases in the company for provisioning the standard elk stack and the standard PagerDuty alerting solution, etc. And for the most part, this was extremely successful. We then went off, evangelizing to these teams and working directly with product teams around the company, getting them to use these resources, and they built their own Terraform resources around it in conjunction with us. But then someone had another idea and said, well, they're still writing a lot of code themselves, still a lot of repeated effort going on here. So can we break that down even further? Can we decompose it a bit more? Which we did. And so we had a lot of very small Terraform modules. In fact, some of our modules had just pretty much a single resource. And one of the particular reasons that we thought to do that, apart from trying to reduce repeated effort, was also to kind of enforce conformity hard-coded into the modules. So for example, tagging was a big thing in this company. They wanted consistent tagging across their entire AWS estate. So we hard-coded them into these modules. Everyone uses our modules. Everyone's got consistent tagging. Perfect, brilliant idea, right? Nothing could go wrong with that. Except when we started to work with some of these teams, try and get them to implement it, things didn't really work out so well. The main problem was that it was just far too complicated. Even when we were working with teams that had a relatively simple product, there were so many modules, and modules within modules within modules, so they were nested several layers deep, and they all had to cross-reference each other to stitch them all together. And it was an absolute nightmare to even try and get this to work on a basic level. And sadly, that venture died very quickly. We went back to where we were before with the bigger modules and allowing teams the flexibility to work themselves. Two key reasons. One, well, people weren't particularly keen. They heard the stories from the other teams and said, no, it's a nightmare, don't do it. But also this sort of idea of trying to enforce conformity. Actually, this company already had auditing software that was sending appropriately nagging emails to product owners and team leads anyway. So there wasn't really much point in doing that. So to recap, what we learned is to consider when you try and decompose things down, try and consider, are you actually adding value? I mean, there are some cases where you have a very small Terraform module that does add value. A classic example is a general purpose security group rule provider, which allows you to, you give it 2 security groups and it creates a connection between the 2. That's perfectly valid, that adds a lot of value, and it's kind of discrete in itself. It doesn't need to be involved too much with everything else in the system. Because the other thing to consider is complexity. Inevitably, when you break things down like this, you are adding complexity to your system. So if you're adding a huge amount of value, maybe it's worth the complexity, but if you're not adding too much value, then obviously it simply isn't worth it. The 2 of those combined basically lead to the third, which is usability. If something is too complicated and doesn't add any or not enough value as a trade-off for the complexity, then no one's going to use it. Now, if we deploy our infrastructure, if we deploy our infrastructure as code just once and never go back and revisit that again, do we have any confidence that if we need to run it again, is it going to work? I think that's a very common question, the infrastructure as code and deployment strategies in general. In one particular one project, we started with one product, a single service, which we called Service A. And we did it from scratch. We started with Terraform. We wrote it all in Terraform and deployed it that way. We had tests. We had a framework called Test Kitchen, which tested the modules. Everything seemed great. And then we added another service, which we called Service B. And we weren't very creative with our naming schemas. And we did that again in Terraform. And these blue boundaries here are the states. So each one of those had its own state file in an S3 bucket somewhere. And then it was decided that these 2 services should talk directly to each other. So we updated the Terraform on each side of the services, added them a security group rule to consume the security group ID from one service and apply it to the other. And everything worked, the tests still worked, the services were up, no problems. Until there was a problem. One of the services wasn't working properly, and when someone looked at it, it turned out that it had, in fact, probably been compromised and hacked. And very sensibly, the company's policy was don't wait for the InfoSec analysis of what's actually happened and confirming is it a hack and has it spread, is it anywhere else? You just trash the environment and you start a whole one afresh. And the best way to do that without any downtime is to start the new one first. We would refer to this as a P1 situation, depending on what sort of companies you work for. Then we call it P1, Sev1. Generally, it's considered red alert, pants are on fire, get to it and be quick about it. So we went to try and create a new environment. And it was at that moment that we realized our Terraform didn't run correctly from scratch, which is exactly the time that you don't want to realize that it doesn't run from scratch, really. When you've got managers breathing down your neck saying, could you please make this work quickly? I mean, those weren't his exact words, but it was to that effect. And what made it all the more vexing was it was something really innocuous and simple that had tripped us up. It was just this connection between the 2 services because they consumed data from the state file from each other. So service A depended on service B, but service B depended on service A. And we assumed that Terraform would pick up on a cyclic dependency. We assumed it would be able to resolve such a thing, or at least tell us that there was this dependency and was going to fail to run in our tests. But when we looked at this properly, we realized that we weren't testing things as well as we could have. I'll finish the story of how we resolved that. That's not really the interesting bit. We removed the direct coupling between the two, and we basically just told the service to deploy and had a third state which actually did the stitching. So they were kind of more loosely coupled, which got us out of that jam. The manager was happy. He said, "Thank you very much." But what was the real lesson that we learned was testing. We didn't really test things properly. What we realized was that the testing we were doing was the infrastructure as code equivalent of doing unit tests in traditional software development, which were perfectly valid and useful, but it doesn't tell you anything about what's going on outside your module or your function or your method. It's just testing the internal functionality. So we resolved to remediate this, to do periodic, constant full deployment testings end to end. This made quite a few people in the company nervous. Developers were doing things all the time in the dev environment. Are you sure you're not going to tear down the developer stack and interrupt their testing cycle? Well, maybe. So the way around that was that we provisioned a dedicated infrastructure testing account, which was completely separate, completely isolated. So we were then able to build up and tear down our entire Terraform states with absolute impunity without risk of affecting developers. So now, a very common exercise when you're starting a project using Terraform to manage your infrastructure is deciding how you're going to segment and divvy up your modules and your state files. We were lazy on one particular project where we just thought, well, we can just split them up by the category, the type of resource or module that they are. So we had modules for networking, and they were all in one state together. We had modules for creating databases, and they were all in one state together. Looked a bit like this. So the horizontal strata are the states, and all the smaller blocks inside are the individual modules. And this was okay. I mean, it all makes perfect sense. When someone said, "Can we make a change?" we knew exactly where to look. If we need to add a database, that's going to be in the database state file. We need to add some Route 53 records. It's in the networking state file. The only real problem that we were experiencing was that very rare that you want to just update a Route 53 record. Usually that's part of another activity that you're doing. You're provisioning a new part of the application, so you have Route 53 records, a database, S3 buckets, autoscaling groups, all sorts of things. So we were modifying and updating 5 or 6 different state files to perform one sort of atomic action. And to start with, that didn't really bother us that much. It was a small venture, and things weren't changing that much. But then the company blew up and had experienced explosive growth, which is a great problem to have. I've worked for lots of startups that have had the opposite problem. So I wasn't really complaining, but things were getting a bit difficult because it was at that point where we were doing these sorts of exercises on a near daily basis. And so a whole plethora of other problems were starting to bother us. So not only the fact that we were having to do this sort of arduous task of updating 4 or 5, 6, 7 different state files all the time for everything. There's only a few of us doing it. We set this up, like myself and 2 other people, and we were now the gatekeepers of all the Terraform for the entire company. So we were this huge bottleneck. Anyone that needed anything updating or adding, they were coming to us to get it done. We also noticed that things were slowing down. Each of our runs was, the plan and the apply was taking much longer. And that's because if you keep adding stuff to the state, it's got to keep refreshing and checking the state with the API calls every time. So the more you add, the bigger they get and the slower they get. And that was becoming a problem. But not only that, we're a bit concerned here. We've got a lot of stuff in some of these state files. And it's stuff that goes across the whole company. We've got all our databases in one state file. What happens if we accidentally hit the delete button? We're going to delete the databases of all the services in all the company. So we were really kind of concerned at this point that we need to have a bit of a rethink. So we decided to refactor things around, and we ended up with something that looked a bit more like this. So what we realized was that there are certain activities that you do maybe once per environment. We want to create a new dev environment. I don't know why developers always want to create a new dev environment. Surely you've got enough. No, there's never enough. They want a new dev environment. Okay. So we deploy a state with the environment, which was fairly sizable, but it was a fixed size. Once it was deployed, that was it. And we had a template for doing that, so it didn't have to mess around too much. And the same for onboarding a new team, where we had to create more sort of IAM groups and things like that that gave the relevant permissions for things. And the same, we had a template for deploying sort of the generic service, or there was a few of those in reality, but to get the idea. And as an added bonus, we were no longer the gatekeepers, because we were able to put in this sort of boundary of responsibility. So once we provisioned a team with IAM roles, then they could go off and just manage their own Terraform by themselves. They can look after their own services. And with this structure, also things were much more isolated. If a developer who was inexperienced in Terraform, but was very enthusiastic and not afraid of anything, like most good developers are, and accidentally deletes a service, well, that sucks for them. He's got to buy donuts for everyone, but he's only destroyed one service. He hasn't destroyed something that's going to have such a wide-ranging impact across the entire company. So to recap those lessons, consider scalability. So when you're grouping resources and your modules into states, is it something that's going to keep growing and growing and growing, or is it something that you can make into a more discrete size? Think about the widening impact, the blast radius. So if things go wrong, is it going to have wide impact across the entire company, or can it be isolated to a single piece? That means everything else carries on. And where possible, it doesn't always marry up one-to-one, because companies are strange things. If you can roughly align a boundary with the boundaries of ownership and responsibility, then all the better. Okay, and this brings me on to the final topic, and this is a much more sort of general umbrella one. This isn't something that happened on a particular occasion. This is something that, quite frankly, happens all the time. It happens every time, and I don't think it happens just with Terraform either. So to illustrate what I'm getting about, writing code that is both clean, clear, and dry is a real problem, I'd say, in Terraform, and like I say, other things as well. So this is a very classic code repo for the source code of Terraform. So all the .tf files are where the resources are. TFRs is where you override the default values for variables. But the main thing to note is that you've got two environments, dev and prod, and exactly the same files in each. And if we look at the content, main TF, this would look exactly the same, whether it was production or development. The only difference would be maybe your development environment would be a couple of patch versions ahead with the version. There's nothing you can do about that apart from manually copying it over and manually updating. TFRs, say it just overrides the default values. And the back end, one really annoying but persistent, well, I want to say failure, but it's not really a failure. So it's a limitation of Terraform, is that you can't have interpolation or variables inside the back end definition. You can only hard code it. That's because it has to parse that before it gets the chance to start the engine that resolves and manages the variables. So again, the only difference between prod and dev is the start of the key there. And the only thing you can do is to manually edit that. So there's still this issue, similar to the issue that I described at the very beginning about getting the wrong back end. You can still copy and paste this over and point towards the wrong back end relatively easily and do very bad things. One good thing about this is it is at least clear. It is verbose. You can look at those files in each of those environments. You know exactly what version of what module has been deployed, or at least as far as the code is concerned, what should be there. And if your real-world example is this simple, then you probably don't really worry about that too much. The main thing you're probably worried about is just being careful about the backends. But there have been many attempts to kind of fix this. If you've got a much more complex setup, you want to try and dry your code up a little bit. Something that happened quite a lot of people would say, let's use Git. Let's have Git branches for each environment, which is a terrible idea. If any of you tempted, don't do it, because you're not drying up the code, you're just hiding the fact that you've got repeated code everywhere, and you're just making it worse because you lose all the clarity. You have to tab between the branches all the time, and if you've got changes in flight, you can't just quickly look at something, you've got to stash it. It just makes it even more difficult to work with, so you've gained nothing in terms of drying up your code, and you've just added more complexity, and you've lost a lot of clarity. that doesn't help at all. A very common thing that people use is a tool, or it's just a command for Terraform, which is workspaces. And workspaces sounds like it does exactly what you would want it to do. It creates an isolated version of your deployment for you to deploy. And some people say, I've come to me after I've given this talk before and said, no, we use it very successfully. How dare you say it's a terrible idea? All right, it's not a terrible idea, but it's not really what it's meant for. It's meant for making some temporary changes, like on a feature branch, testing it, and then you tear it down, merge back into your main branch, and everything's tidied up. The main problem for me with workspaces is there's no way, again, in code to define what workspace is and what's in which workspace. So you can't have a file and just look at it and say, we've got 4 workspaces, and we've got this version here, this version here. You can only do it the command line, and even once you've found which you've got, short of actually going in and doing a plan directly on each one, you don't know what's there. Even had some even more obscure attempts where people have written like their own bash script wrappers with like weird symlinking going on to like symlink loads of configs in random places. So there's one version of the code, which to be fair to the guy I'm referencing, it did work, but it was completely incomprehensible. So again, the trade-off is that you've lost all sense of clarity in order to have that dryness. So for me, the only thing that's kind of had any kind of success, and I don't claim this is like the be-all and end-all, it helps a bit, is to use tooling to fill the gaps. And one example of such a tool is a tool called Terragrunt. And Terragrunt is developed by a company called Gruntworks. They also offer a lot of pre-built modules as well. They're quite an active partner of Terraform. And what Terragrunt does is it provides a thin wrapper around Terraform. It has some sort of magic functions that allow you to fill the gaps where you wouldn't normally be able to use interpolation or logical functions in Terraform itself. So if we look at the same example, using Terragrunt instead, you'll notice we've got the same directory structure, but most of the files have now magically disappeared. We've got this new common TFRs at the top, and just the TFRs in each environment. If we look in common, you'll see that we've got this declaration for Terragrunt, and we're defining the remote state. And the important thing is to note is the key. So you can see now that the key is now using this sort of relative path function, which means that even if you were to copy and paste this and use it in some other context, it will have a relative path, so you shouldn't be accidentally attaching to the wrong Terraform state and doing terrible things with it. And we define it once and once only. And you define just once all your instances that, if they have a default value that is correct for 90% of your environments. Everyone's got this special snowflake environment for some reason that has to be so much different. If we look at one of the Terraform TFRs itself, we include the common TFRs at the top. So we basically have that definition included. And then we can define the source where we're going to import modules from. And if we want to override the value for instance type or any other variable, then we can just add that in here. The only thing that you still have to do manually by hand using Terragrunt is the versioning at the end. And the last, when I first used it, you could only have one module per state, which wasn't particularly helpful. We had to hack around that a little bit, because that's not really how I want it to work. It's not how most people work. They seem to have listened to the community, and they've now fixed that. You can now define multiple modules for one state. And it also has a couple of other neat little features, which are not pictured, sadly. I didn't have time to update that, where you can define dependencies between states. So if you want to bootstrap your environment with several different things that need to run in sequence, you can define those dependencies and tell it to apply all, and it will just run through and apply them all. So it can really sort of help out in that sort of CI/CD bootstrapping side of things. So just to recap on that, where possible, keep it dry. Repeated code, I don't need to tell any of you, I'm sure, that repeated code and copying and pasting is a bad idea. It's going to lead to problems. So definitely do that where possible, but probably not at the cost of clarity. Clarity is also equally important. If you have code that's absolutely incomprehensible, then you're still going to have a lot of confusion, and people are still going to make mistakes when they're trying to use that code base. And tooling can help. I know it's not the be-all and end-all, and sometimes tooling can open a can of worms and add its own layer of problems. But certainly it can sort of help maintain a bit of a balance between keeping things dry and keeping things clear. And we're pretty much at the end. There's some additional things which I didn't have time to sort of add, which I couldn't fit into this talk. So you may just want to screen cap this for a little reference, but in particular the last two. Atlantis is a tool which allows you to use GitOps in your development cycle. So basically, you provide a PR. It then publishes the plan, so your plan becomes part of the pull review process. So it can help you catch some errors. So if you have got some of these mistakes going on, hopefully you've got a few more eyes on it. You're not just blindly and happily running it and then raising a PR before someone gets a chance to say, that doesn't look right. Capitan is a very complicated tool, but it's a general purpose templating engine. It has much wider scope than just Terraform, so I thought maybe it's not necessarily the most appropriate thing for it. But do check it out. It allows you to basically compile your resources so everything is explicit and verbose, but you don't hand code it. You use sort of a JSONet templating engine to define how things should look, and then it compiles it as the output instead. So just to sort of bring things together and wrap things up, I've covered module decomposition and how, yes, it's good and makes sense, but don't go too far. How we can have a bit more confidence in running our deployments, making sure that Terraform is it definitely works in every scenario, not just adding as an addition. The structure of the state files and the structure of our code repos in general. And there are a couple of key things that have been sort of threading through here. First one being that whilst infrastructure as code is in many ways very distinct from software development languages, and it's very easy to think that way, and people tend to forget that it is actually still code. And when it comes to writing clean code and when testing your code, you shouldn't treat it any differently. But more importantly and more interestingly, I think, is that whilst tooling, as I mentioned in this last section, can help, it's not really the tools that are the problem. A lot of the time, it's how we use the tools, and it's the way we use our tools, especially in relation to the company and the businesses that we're working in. So, whilst it's tempting to stick to a semantically clean and pure approach where everything is logical and makes perfect sense, sometimes that doesn't yield the best results. It sometimes is much more important to pay attention to the culture and the size of your company, how that's evolving and how that's going to change, and take that into account when designing your deployments. And that's it from me, so thank you very much for listening. I believe we have time for questions. Yes?
Yeah, plenty of time for questions. Anybody? No?
What are the alternatives to Terraform, and how do they compare?
Ooh, good question. If there are any of the same kind of caliber, I haven't encountered them. I mean, like I said, there is CloudFormation. A lot of people, especially people who are pure AWS focused, are quite happy with CloudFormation, and they think CloudFormation's brilliant. And CloudFormation does have a couple of features which are, again, very AWS specific that make it perhaps a better option. But if you, in my experience, if you do anything outside of AWS, it is restrictive, and then you've just kind of got to import your CloudFormation into something else. Either Terraform, you can import CloudFormation assets into Terraform, or again, you start writing your own stuff, your own bash scripts and Python.
Is Cloudera anywhere near it?
If it is, I haven't used it. I haven't even come across it. Terraform has become such a industry standard that that's what I see. You look on any kind of job spec, it's Terraform.
When it comes to storing modules in Git and then managing them and tagging the versions, how would you recommend laying that out into different repositories and that kind of thing?
Yeah, I personally would say one module per repository, unless you're in some way restricted. We have had use cases where we've had a repository which had lots of modules inside. I find that kind of, again, it comes down to the clarity issue. It gets a bit more confusing because you've got these sort of nested modules. It also means that you've got one version for multiple modules, because if it's just one Git repo, you can only tag it once, right? So if you've got 3 or 4 modules, even if they're related modules, if you want to update one, it's just a minor update, but then you've got to apply that tag to everything. So for me, it's much cleaner to go with one repository for one module.
Anybody? Okay, thank you very much.
Thank you.